So let's say we had two functions expressed in different forms. We have p of x equals 4 minus x, and that's expressed in equation form. Then we have q of x, which is expressed in graph form. This is not drawn to scale. It's -1, -2, -3, 1, 2, 3, 1, 2, 3, -1, -2, -3. This is not drawn to scale. I just drew it how I wanted to draw it in a short amount of time. But let's say we want to know what p of q of 1 is. Well, if you watch the other video where we dealt with h of g of f 43, then you would know. Oh wait, that's on. I drew that too far. Hold on, give me a second. If you watched my previous video, we dealt with this before. We solved for the inner first, then this part, and then this part. And that's the same thing we're gonna do here. We're gonna solve for q of 1 first, and then p of what q of 1 equals. So we don't actually need an equation to solve for q. No, that's not q, that's the g. Q of 1, because it's already on the graph. This is 1 right here. And if we go down to where the graph is, to this point, this is the coordinate 1 of -1, -2, -3, -4, -5, -5. And because the y coordinate is -5, when the x coordinate is 1, then q of 1 is equal to -5. If you already don't know, the x-axis is the x, and the y-axis is pretty much just f of x, or in this case, q of x. So just make sure you have that in mind. So now that we have -5 as q over 1, we can now input p of -5. Now, unfortunately, we don't have a graph representing p of x, but we do have an equation, so we have to plug it into that equation. So if you plug that in, you got 4 minus -5, which is pretty much just 4 plus 5, and we end up with 9. So we can conclude that p of q, keep writing g's, p of q of 1 equals 9.